Hello, everyone. As mentioned in the introduction, my name is Krzysztof, and today I want to talk to you about Service Mesh. I work for a company called Allegro. For those of you unfamiliar with it, it is one of the biggest e-commerce websites in the world. I'm part of the team that's operating at the edge of business software and the technical platform. We provide libraries and services that allow business teams to focus on developing customer-facing features. Our most prominent responsibility is service discovery. In the past, Service Mesh has been called the world's most overhyped technology. At Allegro, we've been developing and running it for almost 2 years, which gives me a unique perspective on which aspects of the service mesh are the most useful in a large and heterogeneous environment like Allegro. In this talk, I will try to separate fact from fiction and give you examples based on our own experience, showing where service mesh really shines and where it is a little of a pain in a butt. To give you some idea of the scale of the service mesh that we're operating at Allegro, last Christmas, we almost surpassed the 2 million requests per second barrier. We were just 21,000 requests per second shy of that. And our biggest cluster has almost 14,000 live instances. All right. For those of you who are unfamiliar with the technology, let's start with defining what service mesh is and how it works. Normally, when you make a HTTP request from your application to another application, it just opens up the connection to the destination, transfers the data, and that's it. With Service Mesh, there is a second component at each end of the conversation called the proxy. And the application does not directly communicate with another application. It just connects to the proxy, and the proxy knows how to talk to the other application. Right now, you might be thinking, why on earth would I want to add another layer of complexity between the services? It adds latency, consumes resources, and it needs to be deployed and maintained somehow. Well, when you introduce a proxy between the services and abstract away the communication, the application only talks to the proxy and it does not care what happens next. Interesting things happen. First of all, the application does not need to know where the destination is. Its only concern is to talk to a particular service. It just tells the proxy, I want to talk to service B, and the proxy knows where that is. This solves the service discovery problem. Okay, but what is so special about it? There is plenty of software that does service discovery. The interesting part is that many of them require some sort of a client library to talk to the discovery servers. So if your organization is using 10 different languages, you will need 10 different libraries for those languages. And when you need to introduce changes to the discovery mechanism, for example, you would implement something like a canary feature. Then what you need to do is implement that feature in the 10 different languages and libraries that you support, release those libraries, then update every service that is using it, then deploy those services to dev, test, and prod environments. And lastly, hope that you did not mess up anywhere, because if you did, then you have to do it all over again. So a simple change in a big organization can take a quarter or two to implement, but with Service Mesh, it is just a configuration change. But how do these changes get propagated to the proxy component? Well, the proxy component can be configured statically via files or dynamically by the management servers. So there are two layers in Service Mesh, management and data. Management servers are used to drive the configuration of the data layer, and the data layer is responsible for routing the packets according to the configuration sent by the management server or that are defined statically. So, for example, if we wanted to make a transition from HTTP to HTTPS, it would look something like this. First, the management server sends an update to all of the proxies. Start listening for HTTPS traffic on port X and use these TLS settings. Then we wait for every proxy to be listening on HTTPS. And after that, we send a second update, start sending encrypted HTTPS traffic using the TLS settings provided. It is way easier to accomplish this than going through every service and every library one by one. And what's the best? You do not have to redeploy every application in your whole infrastructure. To reiterate, when we introduce proxies between the services, we can do anything we want when it comes to the traffic between them. Change protocols like from HTTP1 to HTTP2, encrypt the traffic, and so on. Now let's talk about some choices that we've made. In Allegro, we chose Envoy as the data layer. It is an open source project. It is fast, reliable. It has a big community and a lot of features. One of them is the ability to do a full binary reload without dropping any connections, which is really handy in the VM workloads that we are running. We cannot tolerate service downtime when we upgrade the data layer. As for the management servers, we wrote it ourselves, mostly because off-the-shelf solutions did not fully support all of the features that we needed, and they did not integrate efficiently with existing software that we are using. After running it for 2 months in production, we've open sourced it at github.com/allegro/envoy control. You can check it out there. All right, service mesh takes care of the service discovery and routing of the requests. Let's think what else we can do with it. We showed that we can direct the traffic wherever we want. So things like canary deployments, weighted load balancing, and custom routings are easy to do. If all of the traffic goes through the proxy, we can obviously look at that traffic. Every parameter of an HTTP request can be recorded and published as statistics. This means that we can see how many requests per second there are, how quickly the service is responding, the P99, P95 maximum times, and so on. What are the status codes, how much data is transferred, etc. And again, you do not have to do this for the 10 or 12 or so languages that you support in your infrastructure. The proxy does that for you. All right, we have routing, visibility, what else? If we can look at the data, we can also modify the data. The application does not care. It just knows about the proxy. So what can we do? A request failed? Let me retry that for you. One instance is returning 500 errors. Let's temporarily remove it from the load balancing list while it's recovering. The traffic is not encrypted. Let's encrypt it so that it's safe. As long as the application and the proxy itself tags to each other the same way it has, we can do whatever we want between the proxies. All right, I've told you what's possible with service mesh. Now let's go through a couple of things that we've implemented in Allegro and see how useful they are. The last major feature that was implemented was the security layer, which consists of mutual TLS, which means that the client will authenticate the server and confirm its identity, as well as the server will authenticate the client. Usually it goes only one way. So for example, when I connect to my bank website, my browser will check if the server is legitimate. IP-based authentication, which means that only selected IP ranges will be allowed to access a particular service. And OAuth, which is still in progress. Usually, people talk about MTLS in terms of encryption and not being able to intercept traffic. But what we found out is that the most useful feature is discovering API clients, which means which services are talking to my service API, and blocking illegitimate traffic. With a couple of lines of YAML, you can configure which services can access which HTTP resources and what action is taken when someone else is trying to access them. This is the unlisted client policy line that you see at the end. And above that, you see the array of clients that are allowed to access a particular resource, an optional list of methods, and a path that the resource is at. It can also be a path prefix or a regular expression that will be matched against the path that the user is requesting. And what happens next is all of the traffic from unlisted clients will be either logged or blocked. And when it's blocked, it means that a 4 or 3 error will be returned to the client, as well as the log will be produced in the application logs. So when suddenly a service gets a burst of traffic that is not expected, we can look at the source of the traffic and figure out what's causing it and actively block it. Here's a screenshot of our help channel at Slack after helping a customer figure out who was responsible for a spike in traffic. To give you a perspective of how much time it saves, here's a screenshot of how I enabled this feature on our 18-year-old PHP monolith. This is a login Kibana with the name of the client, its IP address, status code return, and what action was taken. In this case, it was logged. And it only took one afternoon. Imagine going through that manually, configuring it line by line, and worrying about misconfiguration. And what's worse, working with a language that you do not know. As I mentioned in the beginning, Service Mesh gives great visibility into the platform, and identifying problems is really easy being on duty. Here's a screenshot of a client that's trying to figure out which other client caused a surge of new connections to their service. As an on-duty engineer, I just open up Grafana dashboard, go to the Envoy stats, choose the client service, go to open connections, and voila, I can see that is the Opbox service. The last example I'm going to give is when one of our services had performance issues in one region, and how Service Mesh helped to mitigate that. We've got a message on our Slack help channel that a service is returning 503 errors with messages of connection failure for some percentage of the traffic. Then an engineer from another team realized that the app was exhausting the CPU limits. And after checking the Service Mesh traffic metrics, we can see that the traffic was shifted to another region with healthier instances. This is the divergence that you see in the middle of the graph. And a couple of minutes later, everything went back to normal after bumping the CPU limit. Without Service Mesh, that traffic could have been split equally, which means that more errors would be returned, and that would mean more trouble for our customers. And here is a screenshot of the Service Mesh mechanism kicking in 3 times to do the things that it did. Okay, up to this point, I've told you all of the benefits of the Service Mesh with great examples how it helps us and the developers. But is it all sunshine and roses? Certainly not. Service Mesh adds enough complexity when debugging problems to be enemy number 1 when something goes wrong. When a developer does not know what the problem is, the first suspect is Envoy. It became a meme at our channel, 2 wine glasses and an Envoy logo. If you're Polish, you probably got it right away. Wines and fault are homonyms, words that are spelled the same but mean different things. So the puzzle reads envoy's fault. The second drawback is that proxies in service mesh are usually referred to as transparent proxies, but when you actually deploy them, you find out that they are not completely transparent. So when there is no proxy in between the services, when you try to make a new connection and there is nothing listening on the other end, you will get a connection refused. But when there is a proxy in between, you will always be able to establish the connection to the proxy, and a 503 error will be returned with a message, no healthy upstream. So if your service is relying on this specific behavior, you will need to adjust it. Also, developing on a local machine or a laptop became harder. Without the proxy and MTLS settings, people would just connect to the dev instance and try things out. Now, with a proxy and the security settings, you would not be able to do that. On one hand, we want people to be able to experiment on a live environment, but on the other hand, we do not want them to install some special software or some special certificates to be able to do that. It was a bit of a tough nut to crack, but what we did was set up a special development proxy that was set up in a way that would bypass all of the security mechanism of all of the proxies on the dev environment and allow developers to develop their applications as before. What they needed to do is just set up the proxy on their project to be the address of the development proxy. And the development proxy does not know how to talk to other environments like test environment and prod environment, so it's safe. There were also a couple of other things that surprised us. Envoy, the data layer, is very strict with HTTP protocol. It will lowercase all of the headers, it will merge multiple headers into one list, and it does not tolerate forbidden combination of headers. We knew about those limitations, but we still got caught by surprise in a couple of places. For example, Core.js and Undertow in some specific versions can produce a response with transfer encoding chunked and content length, and Envoy will reject that response and return an error. Request and idle time ones will also change and they need to be adjusted. For example, if your service has a timeout of 120 seconds and a proxy has a timeout of 60 seconds, the request will be terminated after 60 seconds. If your application relies on that specific value, you need to adjust it in the proxy. Also, Envoy will start with as many workers as there are CPUs available. If you're using a hefty VM with plenty of CPUs, that can cause enormous resource consumption with regards to the CPU and the memory usage. And also, Envoy's limits are defined per worker. So a lot of CPUs combined with HTTP1 can cause file descriptor limits to be exhausted, and that can also put enormous pressure in terms of open connections to the services that Envoy is connecting to. As I mentioned in the beginning, we decided to write our own control plane, the management servers. It gave us a lot of flexibility, but it also meant that we had to be really careful not to introduce any bugs in there, because if there is a bug in there, it means that there's no traffic flowing in our mesh, and that means we are in big trouble. For the most part, we did a good job, but there were a couple of places with bumps along the way. We are struggling with the performance of our solution, especially with regards to services that talk to a lot of other services, so like 30, 40, or even more services. Our synchronization mechanism was not good with flapping instances. So for example, if an instance appeared, shortly and then disappeared, we would regenerate all of the configuration that was associated with it unnecessarily. Our test services, which are services that are deployed solely to check the time it takes for a service to be up, from the service to be up to being available in Envoy to be routed to. And those deploys would trigger a lot of unnecessary changes, which meant a lot of CPU spikes and traffic in the data plane. And lastly, we use regular expressions when there was no need to do so. Simple string operations like starts with, contains, ends with would suffice. Okay, so I talked about the good parts, the bad parts, and everything in between. Personally, I believe that service mesh makes sense if you're operating at large enough scale. To sum up, I would like you to remember, service meshes allow us to implement features only once, and they can be used in every application, regardless of the language or framework that is underneath. It gives us great visibility into what's going on in the infrastructure, making it easier for on-duty engineers to figure out what's going on in case of an outage. And it has built-in mechanism that can help minimize the damage when accidents happen. On the other hand, for inexperienced engineers, it might be hard to figure out how the proxy works. The proxies are not completely transparent. You need to tweak a lot of things. And writing a management server is hard and take a lot of time and effort when doing it from scratch. That's it. Thank you very much for your attention. Now, if you have any questions, I'm happy to answer them.